From the frozen tundra to the skies above, Russia has long been a breeding ground for formidable military machines. Among its latest and greatest creations is the Sukhoi Su-57, a fifth-generation fighter jet poised to redefine the rules of aerial warfare. Designed to be a formidable adversary in the skies, the Su-57 embodies Russia's ambition to field a cutting-edge air force capable of challenging the world's best. The Su-57, nicknamed Felon by NATO, is a leap forward in Russian military aviation. It boasts an impressive blend of stealth capabilities, super maneuverability, and advanced avionics, making it a force to be reckoned with in any modern combat scenario. This technological marvel is a testament to Russia's engineering prowess and its determination to maintain a competitive edge in the global military arena. The Su-57's development is a clear indication of the evolving nature of air combat, where stealth, speed, and situational awareness are paramount. Its arrival signals Russia's intent to remain a dominant player in the global aerospace industry and to project power on the international stage. The Su-57's entry into the world stage sets the stage for a new era of aerial competition, primarily against its American counterparts, the Lockheed Martin F-22 Raptor and the Lockheed Martin F-35 Lightning II. These advanced fighter jets represent the pinnacle of military aviation technology, and their capabilities have set the benchmark for fifth-generation aircraft globally. The F-22 Raptor, with its unparalleled stealth and air superiority capabilities, has long been considered the gold standard for modern fighter jets. Its combination of speed, maneuverability, and stealth technology has made it a formidable opponent in any aerial engagement. The F-35 Lightning II, on the other hand, is a versatile multi-role fighter designed for a wider range of missions, including air-to-ground strikes, electronic warfare, and intelligence gathering. The emergence of the Su-57 as a competitor to these American behemoths creates a fascinating dynamic in the global military balance. Each aircraft brings its strengths and weaknesses to the table, and their interactions in future conflicts will undoubtedly shape the landscape of aerial warfare. The Su-57's arrival heralds a new chapter in the ongoing narrative of military aviation. Its technological advancements, coupled with Russia's strategic ambitions, make it a critical player in the global security arena. As the Su-57 takes its place among the world's elite fighter jets, its capabilities and performance will be closely scrutinized by military experts and enthusiasts alike. The Sukhoi Su-57 story began not on the drawing board, but on the radar screens of the 1990s. The collapse of the Soviet Union did little to diminish Russia's military ambitions, and its leaders recognized the need for a next-generation fighter to counter the growing dominance of the United States F-22 Raptor. This realization gave birth to the Perspektivny Aviacyjny Kompleks Frontowej Aviacji, or PAK-FA program, Russia's ambitious initiative to develop a fifth-generation fighter that would surpass its Western counterparts. Sukhoi, a name synonymous with Russian aerospace excellence, was tasked with this daunting challenge. The design brief was clear: create a fighter that seamlessly blends stealth, super maneuverability, and advanced avionics, a technological triumvirate that would define the future of air combat. The PAK-FA program was not merely about building a new jet. It was about showcasing Russia's resurgence as a technological powerhouse capable of competing on the world stage. The Su-57's development was shrouded in secrecy, a testament to the program's strategic importance and Russia's desire to keep its adversaries guessing. On January 29, 2010, the aviation world watched with bated breath as the Su-57 took to the skies for its maiden flight. Piloted by Sergei Bogdan, a seasoned test pilot, the Su-57 performed flawlessly, demonstrating its agility and stability during a 47-minute flight over the Komsomolsk-on-Amur aircraft plant. This momentous occasion marked the beginning of an extensive flight test program designed to push the Su-57 to its limits and validate its capabilities. The following years were a whirlwind of testing, analysis, and refinement. The Su-57 underwent rigorous trials, simulating a wide range of combat scenarios and environmental conditions. From high-altitude intercepts to low-level dogfights, the Su-57 proved its mettle, demonstrating exceptional handling characteristics and a blistering top speed. Its advanced avionics and sensor suite were put through their paces, tracking multiple targets, engaging in electronic warfare, and showcasing its situational awareness capabilities. The testing phase was not without its challenges. The Su-57 program faced delays, setbacks, and technical hurdles, as is common with any complex aerospace development project. However, Sukhoi's engineers persevered, drawing on their expertise and Russia's commitment to fielding a world-class fighter. Each challenge presented an opportunity for improvement, and the Su-57 emerged from this crucible even more capable than initially envisioned. In the realm of modern air combat, where evading detection is paramount, the Su-57 stands out for its advanced stealth capabilities. Its design philosophy revolves around minimizing its radar cross-section, making it incredibly difficult for enemy radar systems to detect and track. This invisibility cloak is achieved through a combination of innovative design features, advanced materials, and meticulous attention to detail. One of the most striking aspects of the Su-57's stealth design is its blended wing-body configuration. Unlike traditional aircraft with distinct wings and fuselage, the Su-57's body seamlessly transitions into its wings, creating a smooth, continuous surface that deflects radar waves away from the source. This blended design not only reduces the aircraft's overall radar cross-section, but also enhances its aerodynamic performance, allowing for greater agility and fuel efficiency. Further enhancing its stealth capabilities are the Su-57's internal weapons bays. Unlike previous generation fighter jets that often carry weapons externally on underwing pylons, the Su-57 conceals its payload within its fuselage. This internal carriage not only reduces drag and improves aerodynamic performance, but also significantly minimizes the aircraft's radar signature, making it even more difficult for enemy radar systems to detect. The Su-57's stealth design extends beyond its shape and configuration. The aircraft's exterior is coated with radar-absorbent materials that absorb radar waves rather than reflecting them back to the source. These radar-absorbent material coatings applied to the aircraft's skin and various components further reduce its radar cross-section, making it appear much smaller and less conspicuous on enemy radar screens. The Su-57 doesn't just slip past enemy defenses, it dominates the skies with its unparalleled maneuverability. This aerial acrobat is designed to outmaneuver its opponents in close-range dogfights, leaving them trailing in its wake. Its super maneuverability stems from a combination of advanced aerodynamic design, powerful thrust vectoring engines, and sophisticated flight control systems. At the heart of the Su-57's agility lie its thrust vectoring engines. These engines, equipped with movable exhaust nozzles, allow the pilot to direct the thrust generated by the engines in different directions. This thrust vectoring capability enables the Su-57 to perform maneuvers that defy the laws of physics, such as the Cobra maneuver, where the aircraft rapidly pitches its nose up to a near vertical angle before quickly returning to level flight. Complementing its thrust vectoring engines is the Su-57's advanced aerodynamic design. Its all-moving tailplanes, combined with its unique wing design, provide exceptional control authority at high angles of attack. This allows the pilot to execute rapid turns, sudden changes in direction, and other maneuvers that would leave most other aircraft struggling to keep up. The Su-57's super maneuverability is not merely a matter of showmanship, it provides a crucial tactical advantage in close-range aerial combat. Its ability to outmaneuver its opponents allows it to quickly gain a positional advantage, lining up its weapons for a decisive strike while evading enemy fire. In the digital age of warfare, information is king, and the Su-57 reigns supreme with its advanced avionics and sensor fusion capabilities. This flying sensor platform gathers vast amounts of data from its surroundings, providing its pilot with an unparalleled level of situational awareness. Its sophisticated sensors, combined with powerful onboard computers, allow the Su-57 to detect, track, and engage multiple targets simultaneously, even in highly contested environments. At the heart of the Su-57's sensor suite is the N036 Bielka active electronically scanned array radar system. This advanced radar system, mounted in the aircraft's nose, provides long-range detection and tracking of aerial targets, even those employing stealth technology. The active electronically scanned array radar's ability to rapidly scan a wide field of view and to shape its radar beams allows it to detect and track multiple targets simultaneously, providing the pilot with a comprehensive picture of the battle space. Complementing its active electronically scanned array radar are the Su-57's infrared search and track system and its electronic warfare suite. The infrared search and track system, mounted in a spherical turret under the aircraft's nose, detects the heat signatures of enemy aircraft, allowing it to passively track targets without emitting any radar signals. This passive detection capability provides a significant tactical advantage, as it allows the Su-57 to remain undetected while tracking its prey. The Su-57's electronic warfare suite is equally impressive, providing it with a comprehensive suite of electronic countermeasures and electronic support measures. The electronic countermeasures system is designed to jam enemy radar and missile guidance systems, while the electronic support measures system detects and analyzes enemy electronic emissions, providing valuable intelligence on enemy forces and their capabilities. Section 4. Breaking the sound barrier, supercruise and beyond. The need for speed is deeply ingrained in the DNA of fighter jets, and the Su-57 is no exception. This speed demon is capable of reaching supersonic speeds without relying on afterburners, a feat known as supercruise. This capability, once the exclusive domain of a select few fighter jets, gives the Su-57 a significant advantage in terms of range, endurance, and combat effectiveness. Supercruise is achieved through a combination of the Su-57's powerful engines, its aerodynamic design, and its lightweight construction. Its Saturn AL-41F1 engines, each capable of generating over 32,500 pounds of thrust, provide the raw power needed to propel the aircraft to supersonic speeds. The Su-57's aerodynamic design, optimized for high-speed flight, minimizes drag and enhances its supersonic performance. The Su-57's supercruise capability offers several tactical advantages. First, it allows the aircraft to quickly reach its target area, reducing its exposure to enemy defenses. Second, it enables the Su-57 to engage in high-speed intercepts, quickly closing the distance with enemy aircraft. Third, supercruise enhances the range and endurance of the Su-57, allowing it to patrol a larger area and remain on station for extended periods. Section 1. Powering the Beast, the Saturn AL-41F1. At the heart of the Sukhoi Su-57's impressive performance lies a pair of powerful engines, the Saturn AL-41F1. These turbofan engines, developed specifically for the Su-57, provide the raw power and agility needed to propel this fifth-generation fighter to supersonic speeds and beyond. The AL-41F1 engines are a testament to Russia's engineering prowess and its commitment to fielding a world-class fighter jet. Each AL-41F1 engine can generate over 32,500 pounds of thrust, giving the Su-57 an impressive thrust-to-weight ratio. This means the Su-57 can accelerate rapidly, climb at steep angles, and achieve supersonic speeds with ease. The engine's high thrust output also allows the Su-57 to perform demanding maneuvers, such as the Cobra maneuver, with precision and control. One of the key features of the AL-41F1 engines is their thrust vectoring capability. This means the exhaust nozzles of the engines can be moved independently, allowing the pilot to direct the thrust generated by the engines in different directions. This thrust vectoring capability significantly enhances the Su-57's maneuverability, allowing it to perform maneuvers that would be impossible for aircraft with conventional engines. The AL-41F1 engines are also designed for reliability and maintainability. They incorporate advanced materials and coatings to withstand the extreme temperatures and pressures of supersonic flight. The engines also feature a modular design, which makes them easier to maintain and repair. This modularity reduces the time and cost required for engine overhauls, increasing the Su-57's operational availability. Section 2. The Future of Thrust, Izdelia 30 and beyond. While the Saturn AL-41F1 engines provide the Su-57 with impressive performance, Russia has even more ambitious plans for its fifth-generation fighter. Enter the Izdelia 30, a next-generation engine currently under development that promises to significantly enhance the Su-57's capabilities. The Izdelia 30 represents Russia's commitment to staying ahead of the curve in military aviation technology. The Izdelia 30 is designed to be more powerful, fuel-efficient, and reliable than the AL-41F1. It incorporates advanced technologies such as increased bypass ratios and improved turbine blade designs to achieve these performance improvements. With the Su-30, the Su-57 is expected to achieve even higher speeds, greater range, and enhanced maneuverability. The increased fuel efficiency of the Su-30 is particularly significant. It will allow the Su-57 to fly longer missions without refueling, increasing its operational range and endurance. This enhanced range will be crucial in vast theaters of operation, such as the Pacific, where the ability to project power over long distances is paramount. The integration of the Su-30 engine into the Su-57 is expected to occur in the coming years, marking a significant upgrade to Russia's most advanced fighter jet. The Sukhoi Su-57 is not just a technological marvel. It's a formidable weapon system designed to dominate the skies. Its armament capabilities are as impressive as its stealth and maneuverability, allowing it to engage a wide range of targets, from enemy aircraft to ground installations, with precision and lethality. The Su-57's arsenal is a testament to Russia's commitment to equipping its armed forces with the most advanced weaponry available. Central to the Su-57's armament philosophy is its internal weapons bays. Unlike previous generation fighter jets that often carry weapons externally on underwing pylons, the Su-57 conceals its payload within its fuselage. This internal carriage not only reduces drag and improves aerodynamic performance, but also significantly minimizes the aircraft's radar signature, preserving its stealth capabilities. The Su-57's internal weapons bays can accommodate a variety of air-to-air missiles, air-to-surface missiles, and precision-guided bombs. This diverse payload allows the Su-57 to adapt to a wide range of mission profiles, from air superiority operations to ground attack missions, with ease. The internal carriage of its weapons also ensures that the Su-57 can maintain its stealth advantage even when fully armed. The flexibility of the Su-57's armament configuration is further enhanced by its external hardpoints. While the internal weapons bays are the primary means of carrying weapons, the Su-57 can also be equipped with external pylons for additional firepower. These external hardpoints can carry a variety of weapons, including air-to-air missiles, bombs, and even electronic warfare pods, further expanding the Su-57's mission capabilities. In the realm of modern air combat, where engagements often occur beyond visual range, the ability to detect, track, and engage enemy aircraft from afar is paramount. The Sukhoi Su-57 excels in this domain thanks to its advanced sensor suite and its complement of long-range air-to-air missiles. These missiles, designed to intercept and destroy enemy aircraft at extended distances, give the Su-57 a decisive advantage in beyond visual range combat. One of the Su-57's primary long-range air-to-air missiles is the R-77, also known by its NATO reporting name AA-12 Adder. The R-77 is a long-range, active radar-guided missile designed to engage enemy aircraft at distances of up to 100 kilometers. Its active radar guidance system allows the missile to home in on its target autonomously, even in environments with heavy electronic countermeasures. The Su-57 can carry multiple R-77 missiles in its internal weapons bays, giving it a significant firepower advantage in beyond visual range engagements. The combination of the Su-57's advanced sensors, its long-range missiles, and its stealth capabilities makes it a formidable opponent in any air superiority scenario. Another potent weapon in the Su-57's arsenal is the R-37M, also known by its NATO reporting name AAX-13 Arrow. The R-37M is a very long-range air-to-air missile designed to engage high-value airborne targets, such as airborne early warning and control, AWACS aircraft, tankers, and electronic warfare platforms. With a range of over 300 kilometers, the R-37M can reach out and touch targets far beyond the reach of most other air-to-air missiles. The R-37M's long range and high speed make it a potent weapon for disrupting enemy air operations. Its ability to engage high-value targets from afar allows the Su-57 to effectively neutralize critical enemy assets, paving the way for friendly forces to gain air superiority. The Sukhoi Su-57 is not just an air superiority fighter, it's also a highly capable strike platform designed to neutralize high-value ground targets with precision and lethality. Its arsenal of air-to-surface missiles and precision-guided bombs allows the Su-57 to engage a wide range of ground targets, from enemy command and control centers to armored vehicles and infrastructure, with devastating effect. One of the Su-57's primary air-to-surface weapons is the Kh-59 Mk2, a long-range standoff cruise missile designed to engage stationary ground targets with high precision. With a range of over 500 kilometers, the Kh-59 Mk2 allows the Su-57 to strike targets deep behind enemy lines while remaining safely outside the range of most air defense systems. The Kh-59 Mk2 is equipped with a variety of guidance systems, including inertial navigation, satellite guidance, and electro-optical guidance, ensuring high accuracy even against well-defended targets. Its large warhead makes it effective against a wide range of targets, including bunkers, bridges, and command posts. In addition to standoff cruise missiles, the Su-57 can also carry a variety of precision-guided bombs. These bombs, equipped with laser guidance systems or satellite guidance systems, allow the Su-57 to engage ground targets with pinpoint accuracy, minimizing collateral damage. The Su-57's internal weapons bays can accommodate a variety of bomb sizes and types, giving it the flexibility to tailor its payload to the specific requirements of each mission. The Sukhoi Su-57 isn't just a marvel of aerodynamic design and raw power, it's a flying supercomputer, its systems interwoven with advanced artificial intelligence that elevates its capabilities to new heights. This integration of AI is not merely about automation, it's about creating a symbiotic relationship between pilot and machine, enhancing situational awareness, reducing workload, and enabling the Su-57 to react to threats with lightning-fast reflexes. One of the key areas where AI is transforming the Su-57's capabilities is in sensor fusion. The Su-57's diverse array of sensors, including its AESA radar, ARST system, and electronic warfare suite, generate a torrent of data. Processing and interpreting this data in real time would be an overwhelming task for a human pilot alone. This is where AI steps in, acting as an invisible co-pilot that sifts through the data deluge, identifying threats, prioritizing targets, and presenting the pilot with a clear and concise tactical picture. The Su-57's AI-powered sensor fusion doesn't just enhance situational awareness, it also enables the aircraft to react to threats autonomously. In high-intensity combat scenarios where split-second decisions can mean the difference between victory and defeat, the Su-57's AI can take over certain tasks, such as threat assessment, countermeasure deployment, and even evasive maneuvering, freeing the pilot to focus on strategic decision-making. This level of automation doesn't diminish the role of the pilot, it elevates it. By offloading routine tasks to the AI, the pilot can devote more time and energy to strategic planning, target prioritization, and coordinating with other aircraft and ground forces. The integration of AI in the Sukhoi Su-57's cockpit isn't about replacing the pilot, it's about creating a more intuitive and efficient working environment. The Su-57's cockpit is designed to foster a seamless partnership between pilot and machine, with AI acting as an extension of the pilot's senses and reflexes. This synergy between human intuition and machine intelligence is what sets the Su-57 apart as a truly next-generation fighter jet. One of the key features of the Su-57's cockpit is its advanced human-machine interface. Gone are the days of cluttered instrument panels and overwhelming displays. The Su-57's HMI is designed for simplicity and clarity, with intuitive controls, touchscreens, and voice commands that allow the pilot to interact with the aircraft effortlessly. The Su-57's AI plays a key role in simplifying the pilot's workload. For example, the AI can monitor the aircraft's systems, flagging any potential issues before they become critical. It can also optimize flight parameters such as altitude, speed, and heading to minimize fuel consumption or maximize range. The Su-57's AI can even assist the pilot in planning and executing complex missions. For example, the AI can analyze mission objectives, terrain data, and enemy defenses to generate optimal flight paths and weapon delivery profiles. This level of AI assistance frees the pilot to focus on the bigger picture, making critical decisions and adapting to changing battlefield conditions. The Sukhoi Su-57 doesn't just fight as a lone wolf, It's designed to operate as a critical node in a networked battle space, sharing information and coordinating attacks with other aircraft, ground forces, and command centers. This networked warfare capability is crucial in modern conflicts, where victory often depends on the ability to share information seamlessly and coordinate actions across multiple domains. At the heart of the Su-57's networked warfare capabilities is its advanced data link system. This system allows the Su-57 to share real-time sensor data, target information, and situational awareness updates with other friendly platforms. This shared awareness creates a common operating picture, enabling coordinated attacks and more effective defense against enemy threats. The Su-57's AI plays a key role in managing this data flow, filtering out irrelevant information and prioritizing critical updates. This ensures that the pilot is not overwhelmed with data and can focus on the most important information. The Su-57's networked warfare capabilities extend beyond simply sharing information. The aircraft can also act as a command and control node, coordinating the actions of other aircraft and ground forces. For example, the Su-57 could use its advanced sensors to detect and track enemy targets, then relay that information to other aircraft or ground-based missile systems for engagement. More than a single purpose, the multi-role mission profile. The Sukhoi Su-57 isn't confined to a single area of expertise. It's a versatile multi-role fighter, a jack-of-all-trades in the aerial arena. This adaptability stems from its inherent design philosophy, which sought to create a platform capable of seamlessly transitioning between air superiority and ground attack missions, a crucial requirement in the dynamic landscape of modern warfare. In the realm of air superiority, the Su-57 reigns supreme. Its combination of stealth, speed, maneuverability, and long-range air-to-air missiles makes it a formidable adversary for any fighter jet in the world. The Su-57 can stealthily penetrate enemy airspace, engage multiple targets simultaneously with its advanced sensors and missiles, and outmaneuver opponents in close-range dogfights with its thrust vectoring engines and aerodynamic agility. But the Su-57's capabilities extend far beyond air-to-air combat. Its internal weapons bays can accommodate a variety of air-to-surface missiles and precision-guided bombs, transforming it into a potent strike platform. The Su-57 can precisely target and destroy enemy infrastructure, command centers, and armored vehicles, providing crucial air support to ground forces. The Su-57's multi-role capabilities are further enhanced by its advanced avionics and AI systems. Its sensor fusion capabilities and AI-assisted decision-making allow it to seamlessly transition between different mission profiles, adapting to changing battlefield conditions and exploiting enemy weaknesses. This adaptability makes the Su-57 a valuable asset in any conflict scenario, from large-scale conventional warfare to more localized counterinsurgency operations. Spearheading a new era, the Su-57's strategic impact. The arrival of the Sukhoi Su-57 isn't just a technological leap, it's a strategic statement, a testament to Russia's determination to maintain a potent and technologically advanced air force capable of projecting power and defending its interests on the global stage. The Su-57 is poised to become a cornerstone of Russia's air power, shaping its military doctrines and influencing its strategic calculus for decades to come. The Su-57's integration into the Russian aerospace forces is a gradual but deliberate process. As production ramps up and more aircraft enter service, the Su-57 is expected to gradually replace older generation fighters, such as the Su-27 and MiG-29, in frontline squadrons. This generational shift will significantly enhance the capabilities of the Russian Air Force, providing it with a qualitative edge in any potential conflict. The Su-57's strategic impact extends beyond its direct combat capabilities. Its presence alone acts as a deterrent, signaling to potential adversaries that Russia possesses a highly capable and technologically advanced air force that should not be underestimated. This deterrent effect is particularly relevant in regions where Russia's interests intersect with those of other major powers, such as Eastern Europe, the Middle East, and the Asia-Pacific. The Su-57's development and deployment also have significant implications for the global balance of power. As other nations, such as China and the United States, continue to develop and field their own fifth-generation fighter jets, the Su-57's emergence adds another layer of complexity to the already intricate web of military capabilities and strategic rivalries. The stealth spectrum, a question of priorities. The realm of fifth-generation fighters is defined by a relentless pursuit of stealth, a quest to evade the ever-watchful eyes of enemy radar systems. Yet, even within this elite group, the approach to stealth varies, reflecting different design philosophies and operational priorities. The Sukhoi Su-57, for instance, while undeniably stealthier than its predecessors, has sparked debate among defense analysts regarding its radar cross-section, or RCS, compared to its American counterparts, the F-22 Raptor and F-35 Lightning II. The F-22 Raptor, with its uncompromising focus on stealth as a cornerstone of its design, is widely regarded as the benchmark for low-observable aircraft. Its meticulously sculpted fuselage, seamlessly integrated weapons bays, and extensive use of radar-absorbent materials result in an RCS that is reportedly orders of magnitude smaller than that of previous-generation fighters. The F-35 Lightning II, while not quite as stealthy as the F-22, still boasts impressive low-observable characteristics. Its design prioritizes a balance of stealth, versatility, and affordability, making it a more cost-effective option for mass production and deployment. The Su-57, in contrast, appears to prioritize a different set of trade-offs, placing a greater emphasis on maneuverability and high-speed performance. This is not to say that the Su-57 is not a stealthy aircraft. It demonstrably incorporates many features designed to minimize its radar signature. However, its design suggests a greater willingness to accept a slightly larger RCS in exchange for enhanced agility and speed, attributes highly valued in the Russian air combat doctrine, which emphasizes close-range engagements and aggressive maneuvering. Section 2. Beyond the horizon, range and endurance. In the vast expanse of the aerial battlefield, range and endurance are more than just statistics. They are strategic assets, dictating the reach and persistence of air power. Fifth-generation fighters, tasked with projecting power across continents and patrolling expansive areas of responsibility, require exceptional range and endurance to fulfill their missions effectively. In this regard, the United States' fifth-generation fighters, the F-22 Raptor and F-35 Lightning II, hold a distinct advantage. The F-22, with its large internal fuel capacity and efficient engines, boasts a combat radius exceeding 800 kilometers, allowing it to penetrate deep into enemy territory, conduct strikes, and return to base without refueling. The F-35, while not as long-ranged as the F-22, still possesses a respectable combat radius of over 1,000 kilometers, exceeding that of most fourth-generation fighters. This range advantage is further bolstered by the United States' extensive network of aerial refueling tankers, extending the reach of its fifth-generation fighters even further. The Sukhoi Su-57, while possessing a respectable combat radius estimated to be around 1,200 kilometers, lags behind its American counterparts in terms of range and endurance. This limitation is partly due to its larger size and heavier weight, as well as its emphasis on high-speed performance, which can come at the expense of fuel efficiency. However, Russia is actively working to address this limitation with the development of the Unveiled 30 engine, which promises to significantly enhance the Su-57's fuel efficiency and consequently its range and endurance. Section 3. The Balancing Act, Agility versus Discretion. The dogfights of yesteryear, where leather-clad pilots engaged in a ballet of twists and turns, may seem like a distant memory, but the value of agility in air combat remains undiminished. Fifth-generation fighters, while designed to engage targets from afar, must also be capable of holding their own in close-range engagements, where maneuverability can mean the difference between victory and defeat. The Sukhoi Su-57, with its emphasis on super-maneuverability, excels in this domain. Its thrust-vectoring engines, combined with its aerodynamically optimized design, allow it to perform maneuvers that defy the laws of physics, outmaneuvering opponents with ease and gaining a positional advantage in close-range encounters. The F-22 Raptor, while not as overtly agile as the Su-57, is no slouch in the maneuverability department. Its thrust-vectoring engines and aerodynamic design give it impressive agility, allowing it to hold its own in a dogfight. However, its design prioritizes stealth and high-speed performance over extreme maneuverability, reflecting a different philosophy regarding the nature of future air combat. The F-35 Lightning II, with its focus on versatility and affordability, occupies a middle ground in terms of maneuverability. While not as agile as the Su-57 or the F-22, it is still a highly capable dogfighter, exceeding the maneuverability of most fourth-generation fighters. Its design reflects a balance of capabilities, prioritizing a blend of stealth, agility, and sensor fusion to achieve combat effectiveness. Section 1. A gradual entry into service. The Sukhoi Su-57, despite its technological prowess and formidable potential, has had a relatively low-key entry into operational service. This measured approach is partly due to budgetary constraints, as Russia's economic realities have tempered its initial ambitious plans for large-scale production. However, this gradual integration also reflects a strategic decision to refine the Su-57's capabilities through rigorous testing and operational evaluation before committing to full-scale deployment. The first Su-57S officially entered service with the Russian Aerospace Forces in late 2020, marking a significant milestone in the program's development. These initial aircraft, however, were primarily intended for operational testing and evaluation, allowing pilots and ground crews to gain valuable experience with the new fighter and identify any areas requiring further refinement. Despite the limited initial deployment, the Su-57 has already seen combat action, albeit in a limited capacity. In 2022, Russia deployed a small number of Su-57S to Syria, providing them with valuable operational experience in a real-world combat environment. While details of their missions remain classified, the deployment served as a crucial test of the Su-57's capabilities and provided valuable data that will undoubtedly inform future upgrades and refinements. The Russian Ministry of Defense has outlined plans to gradually increase the number of Su-57S in service, with a target of 76 aircraft by 2028. This gradual buildup will allow the Russian Aerospace Forces to integrate the Su-57 into its operational doctrines, develop new tactics, and train a cadre of pilots proficient in operating this advanced fighter jet. Section 2. Evolution, not revolution, the path forward. The Sukhoi Su-57, while already a formidable weapon system, is not a static design. It's a constantly evolving platform, its future trajectory shaped by ongoing technological advancements, operational lessons learned, and the evolving nature of aerial warfare. Russia's commitment to maintaining a technological edge in military aviation ensures that the Su-57 will continue to receive upgrades and enhancements, ensuring its relevance and effectiveness for decades to come. One of the most significant areas of focus for future upgrades is the integration of the Unveiled 30 engine. This next-generation engine, currently under development, promises to significantly boost the Su-57's performance, enhancing its speed, range, and maneuverability. The Unveiled 30's increased fuel efficiency will also extend the Su-57's operational range, a crucial factor in vast theaters of operation. Beyond engine upgrades, the Su-57 is also slated to receive enhancements to its avionics, sensor suite, and weaponry. These upgrades will likely focus on enhancing the Su-57's networking capabilities, improving its electronic warfare suite, and integrating new generations of air-to-air and air-to-surface missiles. The Su-57's open architecture design philosophy allows for the seamless integration of future technologies, ensuring its adaptability to evolving threats and changing battlefield conditions. The future of the Su-57 may also include unmanned or optionally manned variants, reflecting the growing trend of autonomy in military aviation. These unmanned variants could be used for a variety of missions, from high-risk reconnaissance and surveillance to electronic warfare, and even strike missions, extending the Su-57's operational reach and effectiveness while minimizing risks to human pilots. The Sukhoi Su-57's journey is far from over. As technology advances and the nature of warfare evolves, the Su-57 will continue to adapt, its capabilities honed through a combination of technological innovation, operational experience, and a relentless pursuit of excellence. Section 1. The Felon's Shadow, a new era in the skies. The Sukhoi Su-57, a testament to Russia's engineering prowess and its unwavering ambition in military aviation, has arrived on the global stage, casting a long shadow over the future of air combat. Its blend of stealth, super maneuverability, and advanced avionics, coupled with its formidable armament, marks a significant leap forward, challenging the established order and ushering in a new era of aerial competition. While the Su-57's stealth capabilities may not yet match the near invisibility of the F-22 Raptor, its design philosophy reflects a different set of priorities, prioritizing a balance of low observability with high-speed performance and exceptional agility. This emphasis on maneuverability, a hallmark of Russian air combat doctrine, suggests a focus on close-range engagements and a willingness to engage in a knife fight in the sky. Despite its impressive capabilities, the Su-57 is not without its challenges. Its development has been marked by delays and budgetary constraints, and its operational deployment, while steadily increasing, remains limited compared to its American counterparts. Furthermore, its range and endurance, though respectable, lag behind the global reach of the F-22 and F-35, a limitation that Russia aims to address with the introduction of the advanced Izdeliye-30 engine. The Su-57's arrival is not merely a technological event, it's a geopolitical statement, a symbol of Russia's resurgence on the world stage and its determination to challenge the established military balance. Its presence in the skies, alongside its fifth-generation counterparts from other nations, heralds an uncertain future, one where the skies are increasingly contested and the rules of engagement are constantly evolving. As the Su-57's capabilities mature and its numbers grow, it will undoubtedly play a pivotal role in shaping the future of air power, casting a long shadow over the geopolitical landscape for decades to come.